Assalamu alaikum. Hi friends, it's Enjeela Shafat here and I welcome you all to my channel Radiology Fundamentals. If you are new to the channel, hit the red subscribe button and the bell icon to watch my next lectures of Radiology Fundamentals. So let's start about today's topic, which is prediction of X-rays, X-ray tube. So whenever there comes a topic of prediction of X-rays, it means how X-rays are produced, what is their origin, how they are formed, where from they originate. So here actually we have to study about the diagnostic X-rays. So we will come across how diagnostic X-rays are formed. Actually diagnostic X-rays are formed in X-ray tubes. You might have seen X-ray tube while going through an X-ray. So let's go towards the diagnostic X-ray tubes. Firstly, let me tell you how these X-rays are formed in X-ray tube. Alright, they are formed by the transfer of energy. So, energy conversion occurs in X-ray tube. What is energy conversion? Energy conversion is the transfer of energy. So, here the transfer of energy occurs. It occurs. Now, question arises: how this transfer of energy occurs in X-ray tube? It occurs when a fast moving stream of electrons suddenly decelerate in the target anode of an X-ray tube. Alright, here anode is a part of X-ray tube that we use in diagnostic X-rays to capture the image. Sorry, not to capture the image, to produce X-rays. Alright, so let's talk about the X-ray tube now. X-ray tube is made up of Pyrex glass that encloses a vacuum containing two electrodes. Here electrodes are cathode and anode. As in physics, we have come across that cathode is a positive charge and anode is a negative charge. But in X-ray tube, it's opposite. In X-ray tube, cathode is negative charged and anode is positive charged. So here negative charged electrons are made by cathode. Alright, X-ray tube. Of an X-ray tube, so electrons are made by cathode in X-ray tube. Cathode is a part of X-ray tube and those electrons are accelerated towards positive anode by high potential difference. Potential difference is a voltage here. Alright, electric pressure we can say that is given to cathode. We give a electric pressure to a cathode here. Question is here, how electrons are produced in X-ray tube? Okay, electrons are produced by the heated tungsten filament. Alright, here the tungsten filament is a part of cathode. So in filament electrons are produced and those electrons are accelerated across the tube to hit the tungsten target. Tungsten here is a material of which the filament is made. Filament is a part of cathode. So filament is made up of tungsten. Note it down. It is made up of tungsten. And when this filament is heated, because of heating, what happens? Heating of a filament, the tungsten gets heated automatically. When the filament is heated, which is made up of tungsten, tungsten gets heated up, isn't it? And that tungsten produces electrons which are then accelerated towards the anode where X-rays are formed. Remember here electrons are made by filament, alright, cathode, filament cathode, and X-rays are formed at anode. Now let us move forward towards the design of X-ray tube. So let's go towards the first part of X-ray tube, which is, it is glass enclosure. Alright, I hope you can observe it and see it very clearly. So when we talk about glass enclosure, means that it is necessary to seal the two electrodes, means cathode and anode of the X-ray tube, in a vacuum. What is vacuum? Vacuum is an empty space in which there is no air or any kind of gas present. So what happens if a gas is present inside the tube? What will happen? the electrons that were being accelerated, means that were going to accelerate towards the anode target, will come up with the gas molecules present in the X-ray tube. When they collide or get together with the gas molecules, what will happen? They will lose their energy. Plus, there might be an ejection of secondary electrons from the gas molecules. And because of this, there would be a wide variation in the tube current and in the energy of X-rays produced. It means the energy of the X-ray will be something else. We might be needing some kind of an energy and we will be getting some different kind of X-rays energy and X-ray energy produced, and the tube current would also be changed. So there will be a wide variation in those two things. So what is the purpose of vacuum here now in the modern X-ray tubes? It is to lower the number plus the speed of accelerated electrons. So they control them. Alright, they control the number and the speed of the accelerated electrons. So let's move towards our second part of X-ray tube, which is cathode. Alright. When we talk about cathode, I've already told you that cathode is a negative terminal of the X-ray tube, negative electrode of the X-ray tube. So it has got a part which is called filament. Here the filament is actually the source of electron for the X-ray tube. The other two parts of cathode are connecting wires which supply both voltage. One wire supplies voltage. Voltage means force which makes electric charge or electrons to move. So it is energy per unit charge, which is here actually average about 10 volts. Alright, and the amperage here is 3 to 5 ampere. Okay, amperage, what amperage means? It's a rate of electron flow. Simply it's an electric current which we give to the filament or cathode. Alright, which is 3 to 5 amperage. I told you that. And that is needed to heat the filament. And a metallic focusing cup. Metallic focusing cup is also a part in X-ray tube which will be discussed later on. Now, the number means the quantity of X-rays produced is totally dependent upon the number of electrons that flow from the filament to the target anode of the tube. Noted here, down here. Now the X-ray tube current is measured in milliamperes. Alright. And what is milliampere? Milliampere refers to the number of electrons flowing per second from the filament to the target. Alright. Now the filament is actually made of tungsten wire. Tungsten is what? Tungsten is a metal. Alright. And tungsten wire is about 0.2 mm in diameter. Now what happens when the current flows through this fine tungsten wire, means a metal? It becomes heated, and we know whenever a metal is heated, its atom absorbs thermal energy. Thermal energy is actually here the energy which is contained in the metal, which is because of temperature. Means this is the energy which is obtained by a metal because of temperature which we have given to it. Alright, due to current. So here I have mentioned that it absorbs the thermal energy, and some of the electrons in this metal acquire enough energy to allow them to move to a small distance from the surface of the metal. So they get distracted from their surface a little bit. Alright. They escape, which is referred to as a process of thermonic emission. So because of thermonic emission, electrons are produced. Noted down here that thermonic emission is the process in which electrons are produced. So we can define thermonic emission as, which may be defined as the emission of electrons resulting from the absorption of thermal energy. Alright. Now the electron cloud that surrounds the filament produced by the thermonic emission is being termed as Edison effect. Alright. The temperature which is needed to heat a pure tungsten filament is about 2200 degree Celsius. It's very important objective type question which should be noted and kept in mind. Now, because of this temperature, there is an emission of electrons. Alright. And what is the temperature? 2200 degree Celsius. Now, electrons are emitted from the tungsten filament from a small cloud in the immediate vicinity of the filament. This collection of negatively charged electrons forms what is called space charge. So here's the definition of space charge, which is the collection of negatively charged electrons. Alright, where? In the vicinity of the filament. Now moving towards focusing cup. When we talk about focusing cup, it is present at filament of cathode. So the cathode focusing surrounds the filament of cathode. The focusing cup is designed so that its electrical forces cause the electron stream to converge onto the target anode in the required size and shape. The focusing cup is usually made of nickel. So here is the purpose of focusing cup, which I have already mentioned. Now moving towards the anode, which is very much important part of an X-ray tube, because this is the part where X-rays are produced. Anodes are actually positive electrodes. As already mentioned, I have already informed you about the same. So when we talk about anode of an X-ray tube, they can be made up of two anodes, either stationary or rotating. Stationary is an ancient one which is not used nowadays, but today we use rotating anode. Moving to the first one, which is stationary anode. The anode of stationary anode X-ray tube consists of a small plate of tungsten. So it is made up of a small plate of tungsten, which is 2 or 3 mm thick, and it is embedded in a large mass of copper. So below it is a mass of copper. The tungsten plate is either square or rectangular in shape. Tungsten is chosen as a target material for several reasons. The reason is that it has got high atomic number 74. Make a note here that the atomic number of tungsten is 74, which is very important as far as the objective type question is concerned. And because of the high atomic number of tungsten, which makes it more efficient for the production of X-rays. Here's the question as well. The answer itself comes that whenever there is a high atomic number of any metal or any substance, it helps to produce X-rays. So X-rays are produced by the substance, by an atom, or we can say by any kind of a metal which has got high atomic number. So here the tungsten is chosen as it has got high atomic number 74. In addition, because of its high melting points, it's able to withstand the temperature produced. So because of the high melting point it has, when here is the question, what is the melting point of tungsten? So the melting point of anode is 3370 degree Celsius. So it's known that the melting point of anode is very much more, and it does not allow it to melt very easily. As I've already told you that we need 2200 degrees Celsius for electrons to be produced from the tungsten filament. So it means the filament has got more melting point as compared to the temperature it needs to produce electrons. All right, so that's why we use tungsten as a target material. Now I told you that we use tungsten embedded in a large mass of copper. Now copper, why we use copper? Copper is a better conductor of heat than tungsten. So the massive copper anode to increase the total thermal capacity of anode and to speed its rate of cooling. Thermal capacity is the quantity of heat necessary to produce unit charge of temperature in a unit mass of material. So let's move towards the diagram of stationary anode. This is the diagram of stationary anode. Make it a very clear note of it, and make sure whenever there comes a question of X-ray tube, you need to write both. In anode you need to write about stationary anode as well as of the rotating anode, and diagram of both stationary anode and rotating anode is necessary. This is the diagram of stationary anode. You can see heated tungsten filament here, tungsten target, copper anode, electrons and envelope. All right, now let's move towards the rotating anode. When we talk of rotating anode, it consists of a large disc of tungsten which rotates at a speed of about 3600 revolutions per minute, which is written as a short form RPM, revolutions per minute, when an exposure is being made. So the purpose of rotating anode, what is the purpose? Question is what is the purpose of rotating anode? So the purpose of rotating anode is to spread the heat produced during the exposure over a large area of the anode. Okay, so it spreads up the heat produced during the exposure. The base of rotating anode disk is made up of molybdenum on graphite because of high capacity than tungsten and low density. That's why it's made up of molybdenum on graphite. Graphite is used because of good heat storage, and main intention is to reduce the heat here, isn't it? So in the rotating anode, the main intention is to reduce the heat as much as possible. Now the another one is a rotor assembly of rotating X-ray tube, which consists of anode stem, which is made up of molybdenum, rotor made up of copper and iron, which induces magnetic field. Third is bearings made up of silver powder or liquid lubricated liquid gallium. Alright. Fourth is stator induction motor, alright, which is used for rotating anode. Here is a diagram of rotating anode. See, this is the cathode assembly. Here is the filament in focusing cup. Then is a glass envelope. Here is a tungsten anode disc. Here is an anode stem. Here is a stator or induction motor. Here is a rotor of induction motor. Alright. Now, let me tell you that the stator causes the rotor to rotate very fast like an electric motor. Alright, stator is also called induction motor. Alright, so this was all about X-ray tube. My next topic will be of units and measurements of X-rays. For any queries, confusions, or any kind of questions regarding this topic, you can comment in the comment section, or you can DM me on my Instagram ID mentioned in the description of video. Or if you want any kind of a notes of these lectures, you can DM me on my Instagram ID. Thank you for watching. Take care.